Hello Algebra, welcome to my online classroom. Algebra 1, this is Chapter 2, Lesson 4, Solving Equations with Variables on Each Side. Alright, in the past you've solved multi-step equations. By the end of this lesson, you should be able to solve equations with a variable on each side and be able to solve equations involving grouping symbols. Alright, and your new vocabulary is identity. When an equation is true for all values of a variable, it is called an identity equation. In this lesson, you'll be solving equations with variables on both sides, where you're going to get one of three things. Your first thing is you'll get a solution that will make the equation true. Your second option is that you may get a solution that makes a false statement, so there is no solution. Your third thing that may happen is that you get an identity equation that is exactly the same on the left-hand side of the equation and the right-hand side of the equation, which is an identity equation. That means it's true for all real numbers. Alright, so let's get started with the first equation. And we're going to solve an equation with variables on each side. You want to make sure that you get all of your variables on one side of the equations and your constants on the other. And there's a couple of different ways you could do this. You could start by subtracting negative 7c from both sides of the equation. You'll get 8 minus 2c equals negative 2. Then subtract your constant of negative 8 from both sides of the equation. You're left with negative 2c equals negative 10. Divide both sides by negative 2, and you find out that your answer is c equals 5. Now, you have an answer, but remember, you need to make sure you check your answer, substituting 5 in the place of c to make sure that you're getting a true statement. Alright, now let's solve 9f minus 6 equals 3f plus 7. So if we have 9f minus 6 equals 3f plus 7, I'm going to start by subtracting the smaller variable value from both sides. That will help me ensure that my variable remains positive. I get 6f minus 6 equals positive 7. Add 6 to both sides. Notice I'm getting my variables on the left-hand side, my constants on the right. I have 6f equals 13. If I divide both sides by 6, I will find out that f is equal to 13 over 6, or I could change that to a mixed number of 2 and 1/6. Alright, let's look at the next one. Okay, sometimes distributive property is easier than trying to simplify the fractions. In this case, I can easily take 1/3 of 18 and 1/3 of 12. So if you have a lot of fractions, you need to consider a couple of strategies before you decide on one that will create more fractions. So 1/3 of 18 will be 6. 1/3 of 12 would be 4q. Make sure I use distributive property here. 6 times 2q is 12q. And 6 times negative 7 is negative 42. Now I want to solve it for q. I'm going to subtract 4q from both sides. That will leave my q variable positive. So I have 6 equals 8q minus 42. Now I'll add 42 to both sides. I get 48 is equal to 8q. Divide both sides by 8. And I find that q is equal to 6. If I put 6 back in the place of q, I should get a true statement. So don't forget to check your answers. Now that I've worked it, I'm going to run through it one more time. There's your original equation. You're using distributive property, subtracting 12q from each side, simplifying, subtracting 6 from each side, dividing each side by 8, negative 8, and you get q is equal to 6. Again, don't forget to check, substitute 6 for q in the original equation to make sure it makes a true statement. Okay, here you have 6 times 3r minus 4 equals 3/8 times 46r plus 8. Alright, sometimes you must distribute. And so let me work this one for you. We did this one in class and I went slow, but some of you probably need to do this again. So here I used the wrong variable. Hold on. Let's use r. So 6 times 3r is 18r minus 24 equals, now this is the part that I had to go slow on in class. People were getting confused. I'm going to take 3/8 and multiply it by 46 over 1r. And if I multiply 3/8 times the first term, I have to make sure that I'm multiplying 3/8 times the second term of 8 plus 3/8 times 8 over 1. Now I'm going to cross simplify. I can divide 8 by 2 4 times, and on 46 by 2 23 times. Notice I'm keeping the 18r minus 24, and 3 times 23 would give me 69 over 4r. Then I'll simplify these and I'll have plus 3. Now I know that 69 over 4 would simplify to a mixed number of 17 1/4 r plus 3. Everything stays the same. All I did was change my my improper fraction to a mixed number. So I'm going to subtract 17 1/4 r from both sides of the equation. 18r minus 17 1/4 r, and then I still have my negative 24, and I have 3 because this simplifies out. So 18r minus 17 1/4 r is 3/4 r. Minus 24 equals 3. This is a very long problem. Add 24 to both sides. We'll come up here and write right in this space. I have 3/4. I'm going to leave a little room. R is equal to 27. Now what I'm going to have to do is multiply both sides by the reciprocal of 4 over 3. This will simplify out. I'll have r equals 4 over 3 times 27 over 1. I can simplify this, and I'll get 9 times 4 equals 36. So you can see these really are multi-step equations with variables on each side. Go very slow. It is easy to make a mistake. Alright, let's look at another one. Find special solutions. So if we have 8 times 5c minus 2 and 10 times 32 plus 4c, we have the original equation. Use distributive property. 8 times 5c is 40c. 8 times negative 2 is negative 16. 10 times 32 is 320. 10 times 4c is 40c. Now, if you subtract 40c from both sides of the equation, you'll see that you get a value of negative 16 equals 320. That's a false statement. And so in your false statement, you should have a line right here that shows the mathematical symbol for that's a false statement. So since negative 16 can't equal 320, it's a false statement. In this case, this equation has no solution. Alright, let's look at this one. You have 4 times t plus 20 equals 1/5 times 20t plus 400. And I'm looking at, I'm asking myself first, can I take 20 and divide it by 4? Can I take 20 and divide it by 5? And can I take 400 and divide it by 5? If so, in this case, distributive property is easier than multiplying by any reciprocal. So I'm going to change this to, I'm going to multiply and use distributive property. And I'm going to do that on both sides. And I will get 4t plus 80 equals 4t plus 80. If I subtract 4t minus 80 from both sides of the equation, I will get 0 equals 0. And anytime you get 0 equals 0, it's an identity equation, and it's going to be true for all real numbers. So notice that the left-hand side is exactly the same as the right-hand side, and that's what we refer to as an identity equation. Since the expression on each side of the equation is exactly the same, this equation is an identity, so it's true for all real numbers or all values of t. Alright, let's look at this one. You have solve 2 times 4a plus 8 equals 3 times 8a divided by 3 minus 10. Sometimes the clue to doing math well is to being able to read the equation. So let's do distributive property. This would be pretty easy here. I think I can find half or multiply 2 times 4 and 2 times 8. I think I can simplify the 3's out in the denominator on the right hand side and multiply 3 times negative 10 fairly easily. So I will have 8a plus 16 equals 8a minus 30. If I subtract 8a from both sides of the equation, trying to get all my constants on one side and my variables on the other, I'm going to get a false statement because 16 does not equal negative 30. And so in this case, you have no solution. Alright, let's look at the next example. We have 1/7 times 21c minus 56 equals 3 times c minus 8/3. And again, I think that 21 and 56 is a multiple of 7. And I see that if I multiply 3 times c and 3 times negative 8 over 3, that the 3's will cancel out. So I'm willing to do distributive property here. I'll get, well actually, I think I could probably multiply both sides by 7 as well. So sometimes you have more than one way you can do it. I don't particularly like dealing with fractions, so I'm going to do this. 21c minus 56 equals 7, whatever I do to one side, I can do to the other. Alright, this will cancel out. That will leave me 21c minus 56 equals 21, times c minus 8 over 3 equals, and let's see, c, 21 times c and 21 times, that will simplify out. I'll get 21c minus 56 equals 21c, and I can simplify this and still get negative 56. Okay, that's an identity equation. If I subtract 21c plus 56 from both sides of the equation, I'll get 0 equals 0, so that means it's true for all real numbers. And so it's true for all the values of c. Alright, here's a summary for steps for solving equations. You need to make sure you simplify the expressions on each side using distributive property as needed. Sometimes you might want to multiply by the reciprocal to get rid of that denominator. It's just whichever way is easiest for you. Step 2, use the addition or subtraction properties of equality to get the variables on one side and get the numbers or the constants without the variables on the other side, and make sure you're simplifying. And then your last step is to use multiplication or division property of equality to solve. Alright, here you have a couple of things you're looking at. You're solving equations with variables on each side. You want to find the value of h so that the figures at the right have the same area. Well, I know that the formula for the area of a triangle is area equals 1/2 the base times the height. So if I want to set it up as area equals area, then I want to set it up as 1/2. My base of the first triangle is 6. I know that my height will be represented by h, and I'll let that equal 1/2 the base of 10, and this height is h minus 2. Well, 1/2 of 6 is 3, and 3 times h is 3h. And since these are all being multiplied on the right-hand side, I can use multiplicative property, that commutative property of multiplication, to multiply in any order. So I'm going to say 1/2 of 10 is 5. So I have 5 times h, which is 5h, and 5 times negative 2, which is negative 10. So now what I want to do is, let's see, I'm going to subtract 5h from both sides. I want to make sure my variable's positive, and since I have that negative 10, I'm trying to force it into getting a negative divided by a negative as a positive. So I get negative 2h equals negative 10. Divide both sides by negative 2, and I get h is equal to 5. And so I chose to solve it for the variable. Now I can show you another way to do it. You can read the test item and set it up the way I did. You can solve the equation, or you can substitute each value of a, b, c, or d into the equation to see if it makes a true statement. So you can solve it by substitution. I just didn't want to work the problem 4 times. So if you substitute 5 in the place of h, it will look like this. And you'll get 15 is equal to 15. It makes a true statement, so you know 5 has to be the solution, since it makes a true statement. Alright, let's try one more. Find the value of h so that the figures have the same area. Again, I'm trying to find area equals area. I know to find the area of a rectangle, that's length times width. I know to find the area of a triangle, it's 1/2 the base times the height. And so I'll let 6x represent length times width, 1/2. My base is x plus 4. My height of that triangle is 4. And then I will simply multiply. So I'm going to do this. Since I can multiply in any order and get the same value, 1/2 of 4 is 2. So now I have 2 times x plus 4. I have 6x equals 2x plus 8. I'm going to subtract 2x from both sides. I'll get 4x equals 8. Divide both sides by 4, and I get x is equal to 2. Now, 2 times 6 is 12, and then 2 plus 4 is 6, and I need to make sure 1/2, 6 times 4, so 1/2 of 6 is 3, and 3 times 4 is 12, and that's how I know the areas have the same value. And my x has to be 2 in order for those two areas to be exactly the same. Okay, so that's the end of this presentation, and I hope you enjoyed it, and I hope it helped you with your homework.